All right. Happy birthday, Mr. G. Hey! All right. So, what's the pattern? That's the question. How far is each number from zero? Okay. Now, this is not hard. Okay. You're thinking, if you imagine a number line from like negative infinity all the way to zero to positive infinity, how far, let's start with this. How far is four away from zero? Four! All right. That's easy. Four is four away from four. There's only one number to remember, and it's four. What about, let's do two. How far is two away from zero? Two. Okay, these are too easy. What about zero? How far is zero away from zero? Okay, zero. Now, think about this. Negative four. To get to zero, you do negative three, negative two, negative one, zero. So how far is negative four away from zero? It's still four, right? It's not negative four. We're talking about distance. Like how many numbers away is negative 4 from 0? Positive 4. Okay. How many numbers away is negative 2? Distance to 0, 2. Okay. So when we're talking about distance from 0, what did we notice about all of these values? What kind of numbers are all these? Positive, right? You're very good. So what do you notice about negative 4 and 4? Same distance from 0. Doesn't make any sense. Okay. Okay. Does direction matter or just distance? No, comma, distance. Okay. So all we care about is the distance, not the direction, not the negative. Okay. So we're going to put each of those x values on a table. Okay. So we're going to do this thing again down here. So how far is negative 4 away from 0? It's going to be 4. How far is negative 3 away from 0? It's going to be It's going to be 3. How far is negative 2 away from 0? 2. How far is negative 1 away from 0? 1. And then these are pretty straightforward. 0 is 0 away from 0. 1 is 1 away from 0. 2 is 2 away from 0. 3 is 3 away from 0. 4 is 4 away from 0. Again, you're just like counting the numbers to 0. What do you notice about all these values? Again, they're all positive. So graph all these points. Let's do it. Negative 4, 1, 2, 3, 4. 1, 2, 3, 4. Yay. Negative 3, positive 3. Negative 2, positive 2. Negative 1, positive 1. 0, 0. 1, 1. 2, 2. 3, 3. 4, 4. Plot those points. This is not like quadratic. It's not round. It makes a nice straight line. And then it's like it bounces off of the origin and makes a nice straight line. Okay? Flip it over to part 3. I want you to write something down, like at least one thing down on the left and one thing down on the right. What do you notice about the graph, the way it looks, and what do you wonder about the graph, the way it looks? I wonder here. Wonder who made it. I'll give you 2 minutes, 1 minute. Oh yeah. So that Jim must do. It's like copy though, right? Well, there's something about terms you don't like. All right. What did you notice about the graph? What kind of shape does it make? It's like a V, right? Whoop, whoop. No, maybe it's not the best. Whoa. It's like a V shape. If it doesn't go below 0, that means all the values are positive. That's something we notice. Only positive. Anything else you'll notice? Okay. Anything you wonder? I wonder if it could ever be negative? Question mark. Like, can you change it to make it negative? I wonder if, because could it ever curve? Huh. I wonder, what does it all mean? What's the meaning of all this? Well, let's go down to part 4. Let's compare some graphs. All right. Which graphs have a minimum? Which one of these have a bottom? A, B, or C? There could be more than one answer. So does A have a bottom if it keeps going down forever? No. Does B have a bottom? Yeah, it stops right there. Does C have a bottom? Stops right there. So yeah, B comma C, those are both minimums. Okay. Symmetrical. Which graphs are symmetrical? So actually A, B, and C are all symmetrical depending which way you look. Okay. So A is actually symmetrical across y equals x, like across this line or this line, it's symmetrical. B is symmetrical if you cut it down the middle straight up and down. C is symmetrical if you cut it up the middle straight up and down. It just depends which way you orient it. Which graph looks like it has a constant rate of change? Whenever you see constant, that is linear, okay? And the constant rate of change is only A. C is constant, but then it changes, and that change makes it not constant. Which graphs look like two lines are combined? Well, A is one line, but two separate lines looks like C, right? All right. So we're going to name this thing. There's a name for the V shape, okay? And I want you to think of it like with some eyeballs. Does this look like a very happy face or a very sad face? It looks like it's absolutely happy. So we call this the absolute value. Absolute value function. An absolute value function shows the distance from 0. Its graph always has a positive value or 0. You could also say non-negative value. The graph is shaped like a V. So, part 6, an absolute value function is different from a linear or a quadratic function because, and I want you to tell me how C, from that graph, how does C look different than A and B? What are the differences? You write a sentence, and that'll wrap it up for today.